Hey all, welcome. Grab your favorite beverage as we chat around the fire. The topic of the conversation today, very top of mind with the New Zealand Azure region scheduled for launch, is really around mission critical applications and their architecture within Azure. So today we have Leandro, Microsoft Solution Architect, who works with mission critical architectures alongside supporting the technical community. Welcome, Leandro. Are you able to tell us about yourself?
Yeah, absolutely. Thank you. Thanks for having me, Luke, first of all. And yeah, as you mentioned, my name is Leandro. I work in the support for mission critical team at Microsoft for 7 years now. I'm based in Canberra, and it's a beautiful sunny day today, but it's 1 degree. So
It's a
it's,
bit very similar to here in Hamilton, New Zealand. As you can see, it's nice and sunny outside, but it's very cold
you
inside.
know the
So
feeling. Yeah, I'm sure. And I have been working with customers that have solutions that should not go down. And when they do, we have financial impact, we have loss of trust, we have life at risk. And those applications cannot, should not, they can't afford any outages. So happy to share a little bit of my experience during this chat with you and the community today.
Oh, awesome. Thanks. And I think that really, like, we should just start off with, obviously you're working across multiple industries, right? So potentially like healthcare and other very critical services that need these things up and running. But what are the key like patterns and practices to consider when designing these mission critical solutions running on Azure?
Yeah, so that's a good question. And if you are okay with that, there is a long answer, and I wanted to have a little bit of an analogy to explain that in lame terms. But to start with a high level, I like to take the approach we have with security. And the best way for you to prepare and to get a very good level of protection from a security perspective is for you to expect breach, expect being affected by a security breach at any time. That changed the whole perspective of how you prepare, how you design, how you control, how you apply different layers, the security in-depth layer. And when we talk about reliability, is pretty much the same. We should
Yeah.
expect failure. We should expect chaos. We should expect system not working or impacting the production environment. And that changes the whole concept of how you design and how you architect your solutions. And the best way to explain that is with an analogy because there are some terms around technical terms such as SLA, SLO, SLIs, RPO, RTO that can be a
Yeah.
little bit confusing, right? And when you talk about all the different metrics and how they work, it's a little bit tricky. So I'll go with this journey with you and feel free to stop me and ask me questions as we go, but it won't take long. It's just an analogy of Microsoft Azure being a pizza provider. So you as a customer, you are going to order a pizza online and Microsoft has a delivery service promise that the pizza will arrive within 30 minutes. The 30 minutes is what we call the SLA, right? The service level agreement. So it's
Yeah,
a formal contract.
that Microsoft has made to me as a customer that hey, if I go and order this pizza, I expect it to arrive within the 30-minute time frame.
Exactly. So it's an agreement that we are making with our customers. And if the SLA is not met, there might be consequences that might include financial penalties, service credits, license extensions, and in this analogy, you might get a discount, you might get a free dessert, or maybe a voucher for a free pizza next time, right?
Yeah.
So the pizza shop sets its internal goals. For us to meet that 30 minutes, we need to make sure that 90% of deliveries would arrive within 20 minutes. So that's our worst case scenario. The 20 minutes target for the pizza shop is the SLO, the service level objective, right?
So
And the
that's the internal sort of Microsoft objective, even though as a customer you've told me that it will be there within 30 minutes. So that's really the difference between one of the objectives that Microsoft are offering and then the agreement that they've made with me in terms of like creating a buffer there, right?
Yeah, and as a pizza shop owner, you can't have your SLA similar to SLO because if you have that 30 minutes, you might have a risk of going 30 minutes and 2 seconds, 5 seconds. And it doesn't matter. If you go over, you might have a lot of failures and you might not meet that SLA. So to make things a little bit easier for us as the pizza shop owner, let's make that 20 minutes for 90% of our orders. And we know that the worst case scenario, which is the other 10%, is going to be between the 10-minute difference there. So it's something that I can I can define, I can measure my performance and reliability for my workload and application. And in the pizza shop, it's just a way for us to make sure we are going to meet that target, right? And now, as the pizza shop owner, I need to use metrics like the average delivery time, successful deliveries, customer ratings. The metrics, the way of measuring my SLA and SLO, they are called the SLIs, service level indicators. So imagine as the owner, I've got a massive dashboard that shows me the delivery time, the average delivery time, the orders that might be failing that 20 minutes we are talking about, and give me a better visibility of how I'm tracking with my SLOs and SLAs. Does that make sense?
That does make sense because you kind of need the like the service level indicators to prove A, are you meeting your objectives? And then if you're meeting your objectives, are you meeting your agreement that you've already told me as the customer? Like, will my pizza arrive on time? But
Mm.
not only that, but will my pizza be hot?
Yeah.
That's, that's another potential agreement or an indicate or objective that you might have to go. What is like your service level indicator could be is the pizza that we're creating, is it, I don't know, 190 degrees Celsius or something like that?
Yeah, exactly. So now, moving in that story, let's say the pizza shop's computer system crashes and you lose all the orders from the last hour. So we have a metric that is what we call the maximum acceptable data loss. In this case, our recovery point objective, RPO, might be 15 minutes of orders, meaning they can't lose more than 15 minutes worth of orders, right? I need to have some backups or replications in
Yep.
place so that if my system goes down, my everything in the last older than 15 minutes will be there. Obviously, for a pizza shop, that number might be a little bit too much because imagine selling pizzas on a Friday evening and losing all the orders in the last 15 minutes. That is just an example, but you might have an RPO of 0. I can't lose data, or my data loss should be near to 0 or close or almost 0, right? And then you have the time to recover, the time that the pizza shop needs to get back online quickly. And that's what we call the RTO, is the maximum allowable downtime. So if the RTO, for example, is 1 hour,
Yep.
we need to get back, the system needs to get back within that time to avoid disruption business. So in a nutshell, that is what SLA, SLO, SLIs, RPO, and RTO are, and they are very crucial when we are designing mission critical applications. Which lead us
I
to the next question, right? What is a mission critical application? But sorry,
yeah. Yeah, yeah,
let you
we'll
go
we'll
first.
we'll talk about the mission critical applications like very soon. Like what is it? But I think I just want to call out a few things. One is that it's to me like it's all about the business objective. So you might have this SLI around, the amount of pizzas you're delivering or the temperature of that pizza, but
Mm-hmm.
at the top level of the service level agreement that you have, it's about getting, a pizza to me within the 30-minute time frame. So that's the business objective of going, we need to get this pizza out to this customer, but then all the SLOs and the SLIs are really supporting that from a
Mm.
manufacturing or technical level. So it's about the business outcomes that really are driving this, right?
Yeah, and that's a very good point because the way we get customers to realize how that is important is by asking them how much downtime is acceptable for your system. How long can your system be impacted, and how much you're going to lose from a reputation perspective, or money, or the live at risk example as well. So using the pizza shop, if my pizza shop goes down on a Friday evening when there is a massive sport event, that's going to be a massive impact, not only financially, but trust that I have broken with my customers. And they might go and buy with the competitor after that. So I can't afford that kind of outages. And I
Yeah.
need to make sure my system reflects that requirement, that business requirement.
So let's delve into that a bit more. I really like this analogy, and I really like the fact that you've based it on the same premises as, or the same premise as security. Like,
Hmm.
assume you're already in breach. IT and technology is very volatile. So to me, this makes sense. And what I mean by volatile is not only the fact that you're dealing with the laws of physics. So, you know, spinning plates and the cooling and the heat of this hardware, but also all the processes wrapped around it and the support and one change here could affect another change down. Like the butterfly effect is really it's really live in the world of technology. But I think we've touched on two different things here, and they all wrap up into the mission criticality that you've been talking about. Is the difference between disaster recovery and resilience, and like how do you decide what what is mission critical versus what isn't, like based on this? Because from a business perspective, every system is critical, right?
Yeah.
So, but that comes off with trade-offs such as the cost and the complexity of the system. So I'm really interested in your thoughts here.
Yeah, so that's a very interesting question that if you ask 10 people what mission critical is working at Microsoft, they will give you 10 different answers and different views of what a mission critical is. But my personal take on that is any application that its outage may cause business impact, customer impact, financial impact, that is a mission critical application. You have, and that's where it gets a little bit interesting. You have different levels of criticality. But any application that, if I turn the application down right now, you will have people complaining, that's a mission critical, right? But you can't compare a mission critical solution that is a reporting system that is providing you capabilities to see a nice report during business hours. And if it goes down during the weekend, we don't care because we don't use that. You can't compare that to a health solution where if the solution is down, you might have people life at risk in hospitals because they depend on that particular system to keep them alive. So as you can see, there are different levels of criticality, and that might bring us back to that analogy of 30 minutes pizza time. If we go over 30 minutes, that's okay. But over the weekend, we don't have that promotion because our reporting system is only required during business hours. So over the weekend, I can even afford to turn it off, really, to save some time and to save some money. And my SLA only counts between 9 to 5 o'clock in during business hours. Whereas my other application, the health example one, the solution has to be up and running 24 by 7 by 365 days a year. And if we have more than 15 seconds of outage, that's a massive disaster for us. So yeah, that's what a mission critical solution is, and there are different levels of criticality, and that's why the SLA, SLO, and the other metrics we were talking about is going to dictate how you build your mission critical solution. And look, from a working with mission critical customers, most of our customers have an idea of let's build my solution in different availability zones or different regions. Let's create a copy. Let's have backups. And they don't take that in consideration, the metrics we were talking about. The metrics should be the first point of the discussion when designing a mission critical solution,
because it's all about like the business objectives, right, of what this solution is trying to deliver. So
exactly.
if you don't know how critical it is to the business, like you said, there could be financial implications or even brand reputation awareness.
Yeah.
I think that's usually a really good indicator of if the system goes down, is it going to cause you know, brand deprecation or harm? And if it does, then it's most likely a very mission critical application. If it doesn't, or at least it does internally, then maybe it's not as important as some of the others. But yeah, I think I know I'm guilty of it. It's we as a consultant, my job is to deliver technical solutions that enable the business outcomes. And sometimes you just jump in and go, we need to deliver this, and it needs to be multi-region across all availability zones, but without fully understanding the business context, which can lead to increased complexity and cost. Or I could go completely the other way with a single VM running, you know, a pizza shop application that dies in one availability zone. But yeah, so there's always this juggling act, right?
And I have seen that kind of, I consider that a risk of people saying you have a risk because you're not running your application in different regions. And the question is, do you have that business requirement that needs the SLA and the SLO to spread across regions? Because if your SLA is maybe 3 nines, it's not that much, you can get that number of SLAs within a single region using availability zones. So why are you asking me to have an extra region if my business requirement is not, it doesn't need that? So there is a little bit of a misconception about when you talk about availability zones and regions. And I guess our point here is to have that business conversation first. What is acceptable? What is my outage acceptance? Then you came up with the metrics we were talking about, and that's going to dictate how you deploy your services. So, using that analogy again, let's say the two of us now, we buy a pizza shop, right?
Yeah.
We own a pizza shop, and Microsoft now is our service provider, but we have customers and we need to make that SLAs of 30 minutes. However, we don't have enough people to deliver the pizzas. And we realize in our first month that we are not reaching that 90% of 20 minutes delivery time that I use in my example, right? Whose fault is that? Is that Microsoft or yours?
It would be, yeah,
What do you think?
it would be ours, right?
Exactly. Yeah. Microsoft is giving you the SLAs, the metrics, and Microsoft might help you saying, look, if you want to have a pizza shop, we recommend you to have analysis of your area, understand how many orders you're going to have, and make a a simple math where you calculate the number of orders times deliveries, which is multiplied by the number of people you
Yeah.
have, and you might get a specific number of people you need to deliver the pizza so you can reach that SLA. So that's what we call the shared responsibility. Microsoft is giving you the service, and you might have different levels and different sizing. Take that as a gold, silver, and bronze, right?
The medallion, yeah, gold,
Exactly.
silver, and bronze, yeah.
But it's your responsibility to configure those layers and to set expectations for your customers. So when we translate that into Azure world, you have the gold, which would be different regions. So you have New Zealand North, and you have Australia East, for instance, right? Silver would be maybe the single region, but with availability zones. So 3 data centers within your single region. Or maybe a bronze with a single availability zone. And bronze is okay because bronze is that time of the day. And you can have, by the way, different layers within different time frames. For example, my system is up and running all the time, but I don't start delivering pizzas after 6. So 6 p.m. to 12 a.m., that's when I need gold. For everything else, I might need silver during lunchtime, and overnight is bronze. I don't care. So we have customers in that scenario as well.
Yeah.
But I'm just giving you an example of how that can change, and the shared responsibility we have with customers as well.
I always use the analogy when I talk about Azure with customers is, you know, using Microsoft Azure or just the cloud ecosystem in general, whether it's AWS or GCP or anything, because it's like walking into a room filled with Lego blocks, and it's up to you to make sure not to step on the Lego box and go, "Oh, that really hurts," but really to put it together based on what you need out of it, right? So,
Yeah.
you know, depending on your requirements, depends on what you're going to build with that Lego. Is it going to be a Millennium Falcon, or is it going to be a tree? Or is just a block fine? But I think one of the things I want to touch on while we're kind of talking about this as well is a lot of the customers that I work with, they want to go straight to multi-region. And I think the underlying reason for that is, like you said, potentially miscommunication. So these are customers that are used to having diverse data centers. But what I mean, like in New Zealand, for example, within the North Island, you might have a single data center running in Wellington, and then you might have another data center running in Auckland or the top of the North Island. And so you might have like a failover cluster. So the server runs primarily in the top of the North Island, and then there's an issue it fails over to the secondary one. So these customers or these companies are going from resilient systems already, but like based on on-prem one or two data centers into an Azure region that has not only the two data centers, but they could have three or more within the 2 millisecond latency between
Hmm.
them. But not only that, like if you deploy a storage account, for example, within Azure, even if it's LRS, so locally redundant, it's replicated three times, but it's replicated three times within the same availability zone.
Hmm.
So a lot of redundancy already comes built into the box. So there is this, I think there is a conception where two regions equals two data centers
Yeah.
potentially.
Yeah, exactly. And I guess that's one of the most common misconceptions we have with mission critical applications, where people have that idea of, oh, I need reliability. So that is translated into availability zones and regions. It is translated into that as long as you have your metrics. But
Yeah.
metrics is going to dictate how and where you're going to deploy your services. So before you talk about regions and availability zones, you need to tell me the metrics first. And I wanted to show you, and if you allow me, I will share my screen here to
Yeah.
give you a little bit of an overview on how we go from that pizza shop analogy to a proper architecture discussion with customers. So I'm just sharing my screen now. Let me know if you can see
Yep, I can
that
see it.
this is the Azure Mission Critical Well Architected Framework, where we give customers the guidelines on what is a mission critical solution and how to build a mission critical solution. So it's very detailed, and we cover different design areas, and we give you pretty much everything that there is to know so that you can build a reliable solution. But one of the first things in the design methodology of a mission critical workload is to select, see here, point number
Designed
one,
for business
select a
requirements.
reliability tier, the business requirement, exactly to your point. So have a look. I love this example where you have the SLO with the nines here, three nines and a half, four, and this translates into the permitted downtime. So that would be a nice business requirement conversation to have with your to the business itself, right? So it's 8 hour outage okay for you? Would the system be allowed to have that outage, which would be around 10 minutes a week for your environment? And here they can understand, look, we have a mission critical solution, and 1 minute outage would be a lot already. So we might not even afford 1 minute. And then you start deciding how you're going to build your solution. So here, have a look in this particular GIF where we have three nines and you
Yep.
have one single zone. With four nines, you have now two zones in this diagram. If you go to five nines, you have a third, sorry, not zones, regions. So with the five nines, you have a third region here. So the more reliable your solution is, the more nines you need, that's going to tell you how you're going to build your solution. And by the way, Microsoft has a documentation called the Service Level Agreement for Online Services. You can access this link by aka.ms/CSLA, Cloud SLA, right? That link will take you to this page. And this is going to give you all the information about what is the SLA for online services. So let's use a virtual machine as an example, right?
Yep.
So virtual machine, and I love to use this example because, sorry, virtual machine, where is that? Page 89, cool. Have a look here. we talk about some of the definitions and what is the maximum available minutes, the downtime, uptime, percentage, and what have you. But have a look at what's written here. So we have different ways of deploying virtual machines. If you deploy a virtual machine across two or more availability zones in the same region, the uptime SLA that we guarantee is 4 nines. Back to that list that I showed you, 4 nines is a 1 minute outage per week. So that is going, if you have less than 4 nines, that is going to give you a 10% credit. If you have 2 nines, it's a 20% credit, and less than 95%, that will give you 100% of service credit. But my point here, and that's important, this is the SLA for virtual machine deployed across two or more availability zones. If we go down here, have a look at this other example, virtual machines in availability set or same dedicated host group. The SLA has dropped from 4 to 3 nines and a half. And if you go to two virtual machines, V1 and V2, using a premium SSD shared disk, the uptime SLA is 3 nines. So can you see here 3 different SLAs for the same service? The difference is how you deploy it. So the first question is, what is your SLA? What is your SLO? Compared based on that number, that's how you know where and how you need to deploy your services. And this is important to have that kind of level, because if you have an Azure architecture with a lot of moving parts and services, and you have a 4.9 requirement, but you have one service there that has 2 nines, that single service is a massive risk to your application, because you are as strong as your weakest link, right? It's a Achilles heels there in your solution, and that's always the service that goes down, right?
And that's where you may not be meeting your SLO, or your service level indicators would indicate, hey, this is not right. The service doesn't align to the SLA that you've told me as a customer.
Yeah, exactly. And that's why I wanted to give that analogy when the two of us bought a pizza shop, because the shared responsibility is quite important as well. Microsoft is saying here, if you deploy the virtual machines using this setting, we'll give you guaranteed 3 nines of SLA, right? If we go back to that page where we give you a little bit of an SLO estimate of 3 nines, that would be a 10-minute outage per week. So in theory, if you have a virtual machine with Microsoft and that virtual machine is down for 5 minutes, we are still within the SLA. It's not a problem. So if you have an expectation that 10 minutes is too much, you would have to go to another tier, the 3 nines and a half or the 4 nines. But you can't tell Microsoft, look, it's your fault, your service is down, and I'm just a service, someone that's buying your service, and it's your fault that the system is down. It is our fault that the system is down, and we try to make our best to make sure that doesn't happen. But when you look at
physics, right?
Exactly. Yeah, Murphy law.
We could get into conversations around update domains and all the other things going on underneath. But yeah, I think one of the things that I want to touch on here is that the SLAs make sense, and Microsoft as a provider needs the financial accountability to go, we offer, this is our agreement with you. Depending on what you need as a customer really depends on how you architect your solutions. So I think that's really a great call out, and the SLA agreement document, very handy resource in order to back up that information as well. Can we touch a bit on sort of I've got a mission critical application, but it may only be three nines, right? So a single region could be fine. What about how would we determine the difference here between sort of resiliency and then disaster recovery as well? Because I know this term gets used a lot, sort of in the same sentence a lot of the time, where people are talking about its mission critical applications. Not only do we have resiliency in, but disaster recovery as well. And in my mind, they're two separate areas to consider as part of an overall solution, but they're not. They mean two completely different things. So, are you able to talk
Yeah.
a bit about what you think here?
Yeah, definitely. So, with the resiliency side of things, we just want to make sure that this, if something goes down, the system can gradually keep running, or if there is a problem in my production environment, or if one of my availability zones are impacted, my system is still up and running, and the customer impact is quite small or none at all because we have replications happening and the traffic can be switched over automatically. So if my region goes down, I'm fine. But let's use your example where you have one region and three availability zones, right? So you need to consider the fact that the region might be impacted. And there's always the conversation of what are the odds of a whole region being impacted? Because when we talk about region, for those who don't know, region, as the name says, is a region where we have most of the time three data centers within one single data center. So technically speaking, we have one single building, a massive building in a specific region. And within that building, we have three buildings. It's a data center inside a data center. There are some exceptions, and in some places we actually have three separate buildings. But let's imagine three separate data centers within New Zealand North.
Yeah.
In that case, your whole solution is running in a single region. What are the odds of your solution, your region getting impacted? We have seen that in the past. And I'm not talking about only Microsoft, I'm talking about service providers in general. That happens. We have seen, for example, floods and storms and tornadoes. And I have a lot of examples where similar things happened within different regions. And the one that I like the most.
There was a cooling incident, I think, in Australia East comes to mind when you start talking about this. But yeah.
Yeah, September last year. I remember that quite well. And it was, I'll share a little bit of story when that happened after this. But
Yeah.
with the alt, and that one was a availability zone outage. So one of the three availability zones were impacted, but the region was still up and running, right? So your whole system is running in that single region, three nines, and you're meeting your SLAs. But
Yep.
what if something happens within that region? What is your backup plan? There is a small risk, and that's the kind of conversation that people only realize how important when it actually happens. It's like toilet paper. You never understand how important toilet paper is until you run out of toilet paper, right? So
Especially during lockdowns and the COVID-19 pandemic, right? Yeah.
exactly. And in that case, if your region is impacted, and I wanted to give an example where there was an external update that happened a couple of years ago, that was released by one of our partners. And that update didn't go through the Microsoft update life cycle. So when Microsoft release updates, we release in different update domains within the regions and the availability zones themselves. So you get updates gradually. So if there's a problem with the update, you would see that coming within your resiliency, right? But there was an update released externally that was applied to different regions. And that particular service was impacted in multiple regions. So imagine you have a solution that runs in 4 nines or 5 nines. You have 3 regions. You have, for example, New Zealand North, Australia East, and Australia Southeast. And that update brought down all the 3 regions at the same time. So people have the idea of, what are the odds of my availability, my region going down? It happens not the fact of the region is going down per se, but
But
something,
access to the region could
yeah,
potentially go down. Yep.
and updates, changes. That is one of the most common ways to have these kind of outages as well. And that's one of the changes, impacts we have the most with mission critical applications. So you might have something that brings everything down. What if that happens? That when your BCDR, your disaster recovery, comes into play. And that when the RPO and RTO conversation also comes into play. So I have my region and I can deploy the whole thing in a brand new region, fully automated within 30 minutes. That might be your RPO and RTO, and the data loss could be 15 minutes, because even though we have the 3 nines in my region, I still have some replication going on in the back end there. So they are so reliability and disaster recovery are part of your resiliency. Does that make sense? So
It
reliability
does. Yep.
is just one extra topic, as well as disaster recovery. So you can have resiliency. So you can have the reliability to keep it up and running. You have the assurance that if something goes down, you can recover and you can learn from that outage as well. And if we can go deeper into load testing and chaos engineering and making that part of your deployment life cycle, so you always have an outage as part of your deployment, a controlled outage, so you can make sure that if something goes down, you know what to do. You have the process, you have monitoring in place, because you were built for failures. Failure is part of your day-to-day job. Go
Like,
to work.
yeah, like the security analogy that you used earlier, right?
Exactly.
Assume breach, assume chaos.
Yeah. So what is the best way to assume chaos than inflicting chaos? We have a release tomorrow. We're doing a blue-green deployment. So blue is my production. I deploy green parallel. But before we change to green, let's break green. Let's break the AKS cluster. Let's see if my SLA and let's simulate an availability zone going down. Based on my architecture in the 3 nines, I should not have any impact. So let's have a look at monitoring. Would monitoring pick that up? Let's at the same time simulate that pizza shop at 6 o'clock on a Friday in the middle of the state of origin, or a massive footy, or the I don't know.
Oh, I dare want to be working that day when that happens.
So and you can have that kind of simulations and inflicting controlled chaos to see if you're going to gracefully survive that kind of impact. Let's
So,
simulate bringing down the whole region. Could we bring the whole thing back online within the RPO and RTO?
so what services within, there's a couple of things that come to mind here. One is around, okay, being able to deploy and test these services before they go into production or the user's hands. So there's a continuous integration, continuous deployment aspect of it. But there's also, how do you test? What tools and services does Microsoft offer in order to validate that my service is resilient, or what risks do I have around, okay, this firewall is blocking this traffic on this network security group, and now I can't access my application. Like, how do you test the chaos that's happening here?
Yeah, so the first step there, the first requirement is making sure you have a controlled way to deploy your infrastructure using DevOps. So DevOps is the way so that you don't have any risks of manual intervention or someone missing a setting or a configuration. And whatever you do in your test environment can be replicated exactly the same in pre-prod and production. And DevOps will create that whole process for you to give you that extra peace of mind. However, changes in production updates, any kind of updates, are one of the most common causes of outages within any online service, actually. So if you work in cloud operations or engineering, you know that changes are always at fault. Someone changed something and something went down, right? That's why in the mission critical reference architecture, we recommend having both application and infrastructure deployed at the same time so that all the testings are done no matter what change you make. So let me give you an example. You have
Yep.
a bunch of AKS clusters and you have an application running in AKS and you have application gateways, you have application gateway for containers, you have Cosmos DB, you have different services, service bus, whatever, and then you want to make sure that when you deploy a change within the application, within the cluster, the AKS cluster, you're going through all your testing throughout the whole thing again, because of that domino effect, where the butterfly effect you mentioned, where one small change here can cause a domino effect across my environment. My infrastructure might not like that new application version you've got. So we recommend having that single deployment across the board for everything. And that's what we do at Microsoft where we can. So all the deployments go through the same testing process. So it doesn't matter if you're changing a setting in the virtual machine by enabling, I don't know, changing a disk setting, you go through the whole thing again. And that will give you that extra assurance that your solution would be reliable. And the other thing as well is that inflicting chaos, right? So we don't know what's going to happen if my AKS cluster lose access to my local database within my availability zone. We expect that to fail over automatically to my other availability zone. But that's the theory.
Yeah.
What normally happens is we only know that when there's actually an outage, right? So chaos engineering gives you that ability of, let's try that. Let's break something. Let's break that exactly scenario you just mentioned. Or let's look back in the last year of everything that caused an outage in our environment. We had an outage of the September one, where my availability zone was down. We have an outage where we had a service that was impacted and my performance was impacted for a specific service. So we changed architecture to cope with that change, with that outage. How do we put that into practice? How do we test that? So Chaos Studio would be the solution at Microsoft where you can simulate some of those problems. And the best thing is you can have a chaos happening at the same time you're running a load test with your worst case scenario, all users connected at the same time during a promotion, for example, and having that chaos, all of that as part of your CI/CD pipelines. And you can have metrics saying, we expect this to not have any impact in my environment. If that is true, go ahead with the deployment. If you have any impact over 2 milliseconds, over 10 seconds of outage, I might have a synthetic kind of transactional
Yep.
test,
Just to
and we
verify.
can use that to measure if that goes below my threshold. I've got a gauge there saying we should go back to review that pipeline and the architecture and do whatever change we have to do to the environment. So you can pretty much automate deployment, testing, and chaos within your release lifecycle, your DevOps process, so
Yep.
that when it happens, and I've got a funny story back in September when we had that outage. We had a bunch of customers that were impacted, and they thought they had that reliability. Why did we fail? We had three nines. Three nines as SLO means that we should afford losing a availability zone. Why did we fail? And we had a couple of customers, mission critical customers, that one of them failed the monitoring because they didn't realize in time that the region was down, but they didn't have any customer impact. The customers were they only realized the region that the availability zone was impacted after 5 or 10 minutes, I think. And that's a great problem to have, right? Oh,
Yeah,
okay. We
yeah.
need to go back to monitoring and
Yeah.
alerting because
There
we
was an
couldn't.
issue. Wait, what?
Exactly.
Yeah.
So that's a very nice comparison. And I know and I need to say that I need to word this perfectly. It is really bad when there is an outage within our region, but that's how they realized the solution that they thought was reliable was not. And most of the time, 99% of the time, that's how they find out when there is an outage.
I think, yeah, you touched on a couple of things that I'll just sort of talk to, but one of the things was around having those deployment stamps, right? Having your deployment in this region and then deploying it separately within the same region, having those different stamps so you know which one's test or blue green deployment and which one's there. The other thing is as well, and sort of I just brought it up um, for reference, is really around having like the deployment, having a good understanding of kind of the deployment rings. So
Mm-hmm.
you might do your deployment to a test environment first, then a pilot or a canary environment, and then into like a prod small set of users, and then actual prod as well. So I think I think having those clear makes sense. And I really liked your point around actually testing the infrastructure as well as the application at the same time, because I remember there was an issue where I think it was a lightning strike or something in the US a year or two ago, Chicago, I believe, and it caused issues with an Azure availability zone. And a lot of the services failed over. But I think M365 services sort of had trouble in that particular region, but there was another region that had the exact same sort of electrical surge happen, and then that failed over and everything worked. There was no impact for that from that one, but the other one that did have the issue, actually the services failed over at the same time as like there was a bug in the Outlook client and things like that as well. So being even though as an IT person we might moan about having to do change control and things like that, but some of the impacts of the changes you're making could add up. Like it's testing the entire infrastructure plus applications. Yeah, it's just makes sense in hindsight.
Yeah, and that's why we created that well-architected framework for mission critical because customers were asking, how do I actually build a mission critical workload? it's not only about the SLA, the metrics, the business metrics we were talking about. It's about monitoring. It's about operations, security, and a bunch of different aspects of the architecture that people don't even realize. And they only do, as I mentioned, when something goes wrong, right? But we want to have a nice documentation so that people can follow to make sure they are going to be running a mission critical, reliable, resilient solution following Microsoft best practices and recommendations.
So I'm just weary of time as well. I could talk about this for literally hours, but around, let's say, okay, let's talk about more of the practical elements. So I think we've got a lot of the theory sort of covered off in terms of what reliability means, where disaster recovery comes into play, how we determine what's mission critical versus what's, or the level of mission critical, I should say, versus what's not. Let's talk about some of the potential, like the technical aspects that Azure offers in terms of like the logging and the monitoring of the solution. How do you secure mission critical applications? And what about data? Like, how would you go about sort of storing your data and your managing, and how that all fits together in like enterprise scale landing zone architecture? It's a bit of a dump of questions there, but how does your mission critical applications fit in your overall operational excellence strategy?
Yeah, so with let's start with the monitoring. For mission critical applications, we've historically there is a problem when there is an outage and the ability of business to understand what the problem is and what's the impact to my solution. So we normally have dashboards, right, where we have a lot of metrics and different trends, and it's a pretty dashboard. It looks amazing, and you think you have things going up and things going down. And when there is an outage, people would have to know the dashboard quite well to understand, well, that thing going up there is not good. And sometimes you have the other way around. That thing going down is not good. So first of all, how do you interpret that dashboard? And second of all is, okay, so there is a problem. What is the problem and where is the problem? And what's the business impact, right? We came up with this idea of health models. And health model is a way for you to have your whole solution in a nice diagram overview. So imagine our pizza shop where we have a diagram of my online pizza solution, and then you have some different workflows in your pizza where you have ordering, you have ratings, you have comments, you might have different promotions, and for each one of those services you might have an Azure service providing that. So for example, my Cosmos DB is offering the pizza data storage for ordering as well as promotions. So I know that if my Cosmos DB goes down, ordering will be impacted as well as promotion or something like that, right? Having that visually represented into a nice kind of a diagram, which is similar to an architecture diagram, but converted into a monitoring diagram, so that if my database is impacted, I have traffic light kind of approach where everything is green, but out of nowhere, I see that my ordering and my promotions are now yellow because the database performance is quite bad. So it went from green to yellow, and I can see two things there. I can see where the problem is. If I go through the diagram and all the connections and dependencies, it's like a dependency map, right? I can go down to my database and say, yeah, the problem is right there at Cosmos DB. And I can also tell my business what is the business impact. Cosmos DB is having an issue, and the
Yeah.
business impact right now is that ordering as well as promotions are impacted because both of those services have a dependency on Cosmos DB. So
Because we've
all
defined our SLIs already, so we know what we're monitoring, right?
exactly, and the health model would also have the SLI, the SLO, and you can have those metrics as part of that health modeling as well. So you can track if you are meeting those targets, having a proper SLI, as you mentioned. So monitoring for mission critical should focus on identifying quickly where the problem is and what's the business impact. And the best way to do that is with a health model approach. And most of our customers don't have that. They just have a pretty nice dashboard. And from a data perspective, you also have that different. So when it comes down to data, again, if you use Cosmos DB as an example, Cosmos
Yep.
DB you can have from three nines SLA down to 4.5 or even 5, if I'm not mistaken. And what is going to dictate your data storage and replication and resiliency is back to those business metrics. So with the Cosmos DB example, I can have a tree nine with a single. I'll just have a look at that. The online, the SLA for online services, Cosmos
Yeah, because
DB.
Cosmos DB as a NoSQL option can be a very resilient service, but
Yeah,
do you need it? Like, what is your indication? So
exactly. So if you have a Cosmos DB availability node configured to span two or more Azure regions, which is quite nice, you can have a Cosmos DB spread across two or more regions. You can get 4.9. That's a lot of SLA. That is a very high SLA. And you can still have a Cosmos DB deployed with two nines or three nines. I think the minimum is 3.9. So you can go from 3.9 all the way to 4.9. And again, that's why the business metrics is important because they are going to tell you how you should deploy your services, not the other way around. Not like, we need something reliable, so let's have our data spread across availability zones as well as regions. And the question is, do
but
you need that?
yeah, yeah, and then it touches a bit more as well about, oh well, depending on the requirements of your application, really depend. Like your data might be highly resilient, but doesn't matter if you can't access it because the
Yeah,
front end is down. So
exactly. So is the Achilles heel or
yeah,
the weakest link of your, we call that the composite SLA. So you might have an architecture that requires 4.9s, but when you look at each service independent, you have discrepancy between the SLAs and SLOs. You might have most of them with 4.9s, but or three of them with 3.9s or even 2.9s. So what we normally do is we multiply all of them, like all services with 4.9s, all services with 3.9s, 3.9s, the services with 2.9s. And by multiplying all those SLAs, you have what we call the composite SLA, which is your SLA across the board. So you might have 4.9s, but there is one DNS server in your infrastructure that is only a single virtual machine that only has 2.9s, and that is bringing your composite SLA quite down from 4.9 to maybe 3.9s or 3.9s.
it's quite a common issue that I've seen with customers as well. They'll have
Yeah,
a highly resilient system, but then there's always that one part of it that just doesn't match, or
exactly.
so it's very easy to do. It's a very easy problem to have because like a misconfiguration of something, but it is a very important one to consider.
Yeah.
Yeah. So landing zones. So we have our Azure landing zone set up. So we've got our management group structure with our platform resources. We might have, I don't know, a virtual WAN configured to talk to some on-premises services that might be getting things like our temperature of our pizza and other elements of that. How, like, the mission critical architecture within the Azure logical landscape, so the management groups, and I know we talked a bit about like canary zones previously as well, but how how would you look at architecting or changing, if anything, a standard Microsoft enterprise scale landing zone to really work with mission critical applications?
Yeah,
What considerations?
and that's another thing that people don't realize how important it is, and the fact that we have already a foundation that you can start with. Like, how do I build mission critical applications? First of all, after you have taken those business requirements and you know how and where you deploy your solution, what is the foundations, what is the slab you need to have in your construction before you start building on top of it. And the landing zones is the perfect place to have your foundation ready to go. And with the Azure Mission Critical, we have the landing zone and you have the mission critical baseline architecture within the landing zone. So if you have a landing zone today and you want to have mission critical applications as part of that, you can rely on the mission critical architecture landing zone. And I'll just share my screen again here to show how that works. But it's a great kind of example where you don't have to do this from scratch.
It's an accelerator, right?
Exactly.
It's enabling you to accelerate as a customer this sort of capability and thinking.
Yeah, and it's like that a different way of using that analogy you had with the Lego. And as you can see, I do like Legos, and I think that's a great way of you have your blocks, you have your existing foundation ready to go. And talking about foundation, I've got a perfect example of a Lego foundation. Have a look at this. So this is the Bark-Dur Lego Lord of the Rings,
Yeah,
which is going to be massive. That's the foundation, right? So that would be your landing zone there, and I'm going to build on top of that. So it's taking me quite a while, but
that's awesome. But because you know what you're going to build, because you have your business requirements of building this thing, you know what the foundation's looking like, right? You're not building this little tiny foundation for this massive tower. You know, you've got your SLIs, you've got your SLA, maybe not your SLA because that would be when would you build it by, but yeah.
Yeah, and have a look at that. You do have some very important design strategies and considerations like life cycle of components. How are you going to set up your subscription topology and a bunch of other things? And when you look at the landing zone, there is a mission critical baseline architecture in the Azure landing zone itself. So it's like adding an extra block of your Lego topology, right? So it's just an extra block on top of what you already have. So it's you can adjust, and simply adding a new block to your existing landing zone so that when you build your mission critical applications is already aligned with the whole landing zone from the Azure architecture.
It works inside. It works alongside it. It doesn't replace it.
Exactly. Yeah, you don't have to change your whole landing zone just because of how you are, but just because you're deploying a new mission critical solution.
Well, thank you for your time today. It's been a very enlightening and hopefully very interesting conversation for those who's listening to it. Do you have any last tips, like when you're considering preparing to design or implement these mission critical services? Like particularly for me, which is top in mind, the New Zealand North region is coming very close in New Zealand. So it's a new Azure region. We've been consuming Australia East services for a while. Not that there's anything wrong with that, but it'll be good for a lot of government agencies and other things that need data jurisdiction within Azure. So these mission critical sort of conversations are really top of mind at the moment. But like you've talked about the mission critical accelerator, you've talked about some of the well architected principles. Is there anything else for people that might be interested in designing or implementing these mission critical services that you might want to share or just be aware of to keep in mind?
Yeah, and the New Zealand North is a great opportunity for people to have that conversation, start that business discussion of what are the metrics, what is the how long can we afford having the application down, and the SLA, SLO, the whole conversation. Because New Zealand North is a region with 3 availability zones. If we look at some other regions like Australia Southeast, when we released Australia Southeast, it had only one single region and one single availability zone. So it was tricky to have that extra level of resiliency within the region itself. And Microsoft is making that a little bit more standard across all the different regions, where every new region and all the existing regions will have the availability zones eventually. Melbourne is on the way. New Zealand North is about to get released with the 3 availability zones. So that will give you those different stamps or the different tiers we were talking about. And it's different options for based on your requirements. But if you want to start from the scratch, and if you want to, it's a lot to take in, a lot of things to consider. Go to the well architected framework. Go to the mission critical well architected framework. We tell you what to do, how to do. We give you design considerations. We give you examples. We even give you an architectural solution that you can build following those practices using CI/CD and Chaos Studio and load testing and the whole code of an e-commerce solution, an online solution using Cosmos DB and AKS and a bunch of other services that you can actually picture, like, okay, this is what the architecture looks like. This is what a real thing looks like. I'm a visual learner, so
Yeah.
I like to see things to learn how you actually do. So we have everything there, so you know what to do, you know how to get started. We have the landing zone, that foundation we were talking about. So we've been through that. We had to become resilient. And as part of that learning circle, we created this documentation, which is forged by fire. We failed. We had problems in the past that helped us to have the resiliency we have today, right? So
Yep.
yeah, it's just like a cookbook where you just need to follow and you know what to do and how to do it.
I like that. And I do like the fact that Microsoft eats its own dog food in terms of this. So the guidance that, is being displayed and accessible to me as a customer is essentially the same guidance that Microsoft follows internally to deliver global like resilient solutions, but also take the learning. So if there is an issue, the service is adapted and then public documentation is released so people can learn from and consume these services. I just want to touch on one more thing before we go, and that's really about anti-patterns and things to avoid. And I think we've already covered off a lot of them in terms of thinking about the business. So, like an pattern, as an example, could be this IT person has just come along and deployed it, and we don't have the business context of what it is. So, business context example would be very key to this. Another anti pattern I think we've talked about as well is looking at the overall solution. Like we used that Cosmos DB analogy earlier in terms of, well, you could have a highly redundant service, but there's this one component that's not aligned to the composite SL, like that it's not redundant in the way that
Mm-hmm.
the rest of the system is. Is there any other anti-patterns that come close to top of mind or that you might see customers hit more often than not?
Yeah, I guess the classic one is the assumptions around reliability, right? Let's just build in a specific template that we think is reliable for us, but how does that translate into your requirements? You might be paying a lot of money for an architecture providing reliability that you don't need at the end of the day, or the other way around, where you think you have high expectations about reliability, but when we look at your architecture, it doesn't reflect what you have in place today. And that's why those business metrics is the first thing to start with. Another thing that people also, after they go through that process, they think that mission critical is about the resiliency and the architecture. Reliability is
Yeah.
one out of the five pillars in the well architected framework. And when we ask questions, okay, so you look really reliable, but how do you monitor your solution? How is your security posture today? Or how do you deploy stuff in the cloud? Are you using CI/CD? Are you using DevOps? Do you have ClickOps? Are you doing changes in the portal? Do you have a good monitoring dashboard where it gives you that traffic light approach to identify where the problem is? Uh, and how's your performance wise? Maybe you have a beautiful 4.9 infrastructure, but your performance is really poor. So we need to look at that from an architecture perspective. And
Because
most of the time,
yeah, I think like a lot of you've touched on a really good point there, and it's around we're talking about the availability of systems when we're talking about reliability as well, but like your mission critical requirements could just be latency.
yeah, exactly. Yeah. And when you look at what could bring my solution down, let's walk through some scenarios. So I have a 5.9 application running across three different regions, and it's beautiful. And then you've got a security breach where a global admin account is not using MFA. That account got owned, and that attack deleted all the three zones in a single pipeline. It deleted all the resources and you didn't have backup, or you did have backup but you didn't have immutability. So we have seen scenarios where an account gets owned, the whole system is destroyed, and the backups are deleted.
Yeah.
What then? Where is your 5.9s now? So, and that's something we need to look from an architecture perspective. It's not an operation, it's not a CSOC responsibility only, but it needs to be considered from their architecture all the way down. Another good example is observability. Let's build the architecture and let's leave to cloud operations to monitor, right? We need to look at mission critical. The observability has to come all the way from architecture, and then we can go down all the levels to engineering and operations as well. So a broader view and encapsulating all these different pillars in your architecture itself. So yeah, I would say those are the top two to consider as misconceptions that customers normally have. And if I could add a third one,
Yep.
is that shared responsibility. Oh, my virtual machine is down and it's Microsoft to blame. it is Microsoft's blame. It is our responsibility. But remember about the SLA conversation and the reliability that we provide and the options you have. If you're using a reliability tier that gives you maybe 2 or 3 nines for a virtual machine, you can't complain why you're not getting 4 or 5 nines, right? If you're getting 3 nines, it's within the SLA. If you need more, then it's your responsibility. Back to that example of the pizza shop, where we have a new shop now, the two of us, but we don't have enough people to deliver the pizza for us, and we can't meet that 30 minutes pizza delivery time.
Yeah, yeah. I think we're definitely going to have to go down the pizza model, and yeah, have the world's highly resilient pizza shop on order online and globally available. Yeah. But but I think, yeah, it's a really good point, right? Of knowing why you want something,
Mm.
what is the brand reputation, what is the impact of the system going down, understanding the architectural components, the non-functionals like you've already talked about around monitoring and alerting and observability, and then the functional delivery requirements so people can actually order the pizza and things like that. So, Leandro, thank you very much for coming and talking to me today. I don't know if you've got any closing remarks, but
Yeah, it was great talking to you. Look, thanks for the opportunity. And mission critical and reliability is becoming a hot topic. I guess customers are now realizing how that's important in the worst possible way, which is having impact to their environment. When something bad happens, they go back to the drawing board to consider, I think we should have done this differently. So we want to change that mentality. And that's why I love that security analogy of always expect outage, always expect failures. And that way you can think about different ways your solution might be impacted, and that help you with the design methodology and the concepts from an architecture perspective on how to build resilient solution.
thank you very much. How could people get in touch with you if they want to connect or know more about this stuff?
I'm very active on LinkedIn and X. So in X, I think it's Leandro Eduardo, my X account. And on LinkedIn, you can search Leandro Carvalho. And I'm posting on a daily basis around mission critical and reliability and a bunch of other services at Microsoft as well. So that would be the best way to get in touch. But yeah, I guess that's
Yeah,
pretty much it. Social networking would be the best way.
awesome. Thank you again for coming and speaking to me today, and thank you for all you're doing with the community on X and LinkedIn as well. Cloud changes very often. You know, it's a very competitive landscape, and you're doing a lot to make sure that we all know what's going on. So thank you.
Not a problem.
And
Thanks,
yeah,
Luke.
thank you for listening. Goodbye.
Bye.